Okay, good morning. Today we are learning still we are empirical formula. We are doing the example 3 because each example is different from the other example. The first example was dealing mass, second example percentage mass, and this is also percentage mass, but there is slightly differences in terms of the mole ratio. When you are calculating the mole ratio, there is something that you will see it, and I want to show you how you can handle it. Okay, the percentage composition by mass of an oxide of iron is 70% iron, and 30% oxygen. Determine the empirical formula given that the iron 56 and oxygen 16. So how do you do this? Okay, in the first place, you do the same way. You follow the same format where you say element, you write element here, element. The element that we have is ferron, which is iron, and oxygen. Okay, ferron Fe. I've written the E in a badly way. Okay, ferron F E. Okay, this is the element. Then you write percentage. Since you have percentage, you say percentage mass. You'll write the percentage mass. So the percentage mass of iron according to the equation is 70%, and that one of oxygen is 30%. You won't write the value, don't write the percentage, since you have written here percentage. Okay, then you write molar mass. Molar mass. So the molar mass of iron in the bracket is 56, and that of oxygen is 16. Okay, then you write the number of moles. How do you get the number of moles? You divide this one and this one. You say it's 70 divided by 56, and here you'll say 30 divided by 16. Okay, that's how you get the mass divided by molar mass. Mass divided by molar mass, both sides. That's how you get the number of moles. Okay, let's see what's the value of the number of moles. The value of the number of moles here is 1.25, and here the value of the moles is 1.875. So we have 1.875 and 1.25. So when you want to get now, the next is mole ratio. Mole ratio. You can use a calculator because you're high school, you are required to use calculator. There's no problem. Mole ratio 1.2. Here we have the number of moles 1.25 and 1.875. So we need to get the mole ratio. The mole ratio is always obtained dividing the smallest value in both sides. Dividing the smallest value in both sides. So now 1.25 and 1.875, which one is bigger and which one is smaller? So here both of them, they are 1 they start 1 1, but at the end of the decimal, after the decimal, here we have 2 and here we have 8, which means this one is smaller, this one is smaller. So therefore we divide both sides the smallest value, 1.25, 1.25. So we divide this one and this one, you get it 1 because they are equal. When you divide this one and this one, you will get it something called 1.5. 1.5. So here you get 1.5 when you divide these two, meaning that if the value of the mole ratio is 1 1, or if it's not whole number and there's a decimal place, if the decimal place instead of 5 here, if we have like 3 2 4, if we ignore it, we take the 1. But if this one is more than 4, the decimal point, at the end of the decimal point, after the decimal point, if the value that comes is more than 4, just like 5, like 6, 7, 8, 9, if it is just 6, 7, 8, 9, these values like 7, 6, 8, 9, you round out, you round off, you round. For example, if it is 1.6, 1.6, 1.7, 1.8, 1.9, if it's like that, you round off, you round off. They become is equal to 2, this one is equal also 2, this one is equal to also 2, this one is equal to also 2. But if it is 1.3, 1.2, 1.4, this one you ignore it. This decimals here, you ignore it. So the value will be 1, 1, 1. You take the 1, 1 value. Are you understanding? Okay. If now this one you have here, if it's neither not 3, 4, or 2, and not 6, 7, 8, 9, it can be 1.5. If it's 1.5, this is what you do. This is what you are going to do. Let me wrap the board. This is what you are going to do it. So what are you going to do it? Let us see it. Let me clean the board. If it's 1.5, what do you do? But if it is in between 1.6, 1.7, 1.8, 1.9, above 1.5, you round to the nearest whole number, which is, in this case, 2, 2, 2 to all of them. If it's 1.3, 1.2, 1.1, you round to the nearest whole number, which is 1, 1, 1, 1 only. But if it's exactly 1.5, the way that we have now in this example, what do you do? What do you do? Okay, now we have 1 and 1.5 here. So if you have such values, this is what you do. You have 1 whole mole ratio from iron and 1.5 of oxygen. This is the mole ratio. So what do? You multiply both sides by 10. Multiply by 10. You make it whole number. This decimal. You remove the decimal. By making whole number, you multiply both sides by 10. Why are you multiplying? Where is this 10 coming from? You look this value. You look this value. If this value here, if this value that we have here is a decimal point, just 1.5. So things that can make whole number is 10. You multiply 10. To convert this decimal into whole number, you multiply 10. So the 10 you multiplied here, you also multiply the other side because it's a ratio, both of them. So when you multiply 1 times 10, it's 10. And 1.5 times 10 is 15. Then you divide, now you simplify. When it's here, you simplify the simplest whole number ratio. So by 2, 5. By 2, it's impossible. 2 cannot be divided because any common factor that can divide both of them, let's check it. So this one can be divided by 5. 5, both of them can be divided by 5. By 5, 2. By 5, 3. So you cannot further divide 2 and 3. There is no common factor in between them. So you stop it here. So iron, the value of iron is 2. And that of oxygen is 3. Because 1.5 we got it from 3 and 1 we got it 2 according to the ratio. So the empirical formula is equal to iron 3 oxide. Iron 3 oxide. Iron 3 oxide. Okay, iron 3 oxide. That's the value. That's the empirical formula. I hope you have understood it. Please subscribe and share so that other children or other students, they can also benefit it. Thank you.